Good afternoon. My name's David Munro. I'm a product manager at Google Cloud, and I get to work on Istio. So, first of all, hope everyone had a good lunch. There's nothing like having the first session after lunch because everyone's got nice amount of food and they're starting to get into that nice coma. So let's see if we can wake you up with some nice YAML during the course of the demos and stuff. Anyway, so we're actually here to talk about Istio. We're going to talk a little bit about also API management on Istio. So a couple of demos as well. So, but first of all, why did Google actually go around and actually introduce Istio as an open source project? So let's talk a little bit about the need for a service mesh. So everyone knows microservices are awesome. If you think about traditional applications, monoliths, you actually have all your business logic in one chunk of code. You pick one language, you write your code. To a certain extent, if your application's small and your team's small, it's actually easier. You have one thing to deploy. You have one piece of code that's doing many things. But at the end of the day, again, it's just one piece of code. From where monoliths become more problematic is if you need to scale certain capabilities within that code base independently, it becomes challenging. Everyone's working on the same code base, so if you want to change one thing, you're still pushing the whole application. So, microservices. So, the benefits around microservices are your developers can actually focus on a specific set of business logic. You can pick a language that is more applicable for that particular business logic. So for example, you might use Ruby to write the front end, you might use C++ to write the back end, or Go. So it gives you a lot of flexibility. It also means that you can scale those microservices independently of each other. You can also deploy them independently of each other. The only thing, and as the developer of the front end, I actually don't need to know anything about the ETL pipeline. All I really need to understand is what interfaces or what APIs I need to connect to and what I need to do to make that happen. So it actually becomes there's some definite advantages here. But what happens when you start to really scale microservices? You deploy in multiple regions. You actually, you have a very large number of microservices. You go from maybe 5, 10, 100, maybe to 1,000 microservices. At that point, it becomes very difficult to actually understand exactly which microservice is talking to which other microservice. It's hard to understand, if a specific, in order for you've only got to have one microservice fail, and your application effectively is down. So it's sometimes hard to determine exactly how, which microservice is causing the problem or what's going on within that environment. Another thing that's interesting too is if you're writing these microservices in different languages, each implementation of a given protocol might be slightly different. You've got different developers writing it. As a result of that, actually having the same implementation across the environment can sometimes be difficult and hard to maintain. So maybe microservices aren't so cool after all. There's some challenges there, right? As that application scales, you've really got to start working on how to control that environment. So what do we do in this type of industry? When there's a problem like this, we develop tools effectively. So welcome to Service Mesh. What is Istio? So Istio is an open source project originally kicked off by Google and IBM. It's actually developing a huge amount of traction. There's a lot of interest in Istio. Has anyone actually in this room, just a show of hands, obviously, based on the amount of times Istio's been mentioned in Google Next, I'm pretty sure everyone's heard of it. Who's actually used it? Okay, excellent. There's quite a few. Fantastic. And Istio is actually a fairly broad framework. It provides a lot of capabilities. So let's talk a little bit about what that actually, what we can actually do with Istio. So It's effectively an open service platform that allows you to manage the service interaction. So think you basically start thinking about services first within your environment. The other key thing here is it actually works across both containerized environments as well as VM-based workloads. So, and it could potentially be on-prem as well as on cloud or multi-cloud. There's three main tenets that Istio provides from a value prop perspective. The first tenet is related to providing uniform observability. With Istio, you can effectively get a common set of metrics that are automatically implemented across your environment without actually having to do that from a developer perspective. The developer now can just focus on, you effectively get this from the infrastructure. The developer can focus on the business logic. You get operational agility, the ability to change based on a level 7 context how you want traffic to be traversed through that mesh and what you actually want to do with that. You can also start providing a policy-driven security posture, provide actually service-to-service security, as well as, and this effectively is infrastructure that the infrastructure can provide you. Your software developers now don't have to worry about implementing these type of capabilities. So let's take a little bit of a closer look. Istio architectural components. This is a pretty, I think pretty much every Istio presentation I've seen tends to have this diagram or something similar to it. There are three major control plane components that are part of Istio. Pilot, which we'll talk about, which effectively controls your routing and your forwarding policy. Mixer, which is actually something that's pretty interesting. It provides an extensible model, and we'll talk about some of the things you can do with Mixer. And then you've got Citadel, which provides a lot of your security aspects of Istio. So let's quickly get through this. What can you actually do with security, Istio security? There was actually a really good talk yesterday. I don't know if any of you got to catch it, but it was talk about security in depth. Security is not just a perimeter problem. One of the drawbacks or one of the things that you need to be aware of when you go to microservices is now you've actually opened all these channels of communication between services and between parts of your application. You need to be able to lock them down. So we can use MTLS for that. We also have the ability, and we do that effectively based on service identity and channel attributes. So it's more than actually just providing MTLS. We can also control the level of access. So service A can talk to service B at full access. Service C can talk to service B at maybe read-only access. So you can do things like that as well. If you think about why you support MTLS, this actually gives the ability via Istio to basically do a policy-driven encryption in transit. But that's not all. The other key thing is around strong authentication. Actually authenticating based on a strong service identity. This is important so I can actually make sure that if I have a compromised service, that I can't replay that identity to a different service. Let's talk a little bit about Mixer. So Mixer actually provides really good extensibility. I can effectively use Mixer to interconnect to any backend I want to. I can use Mixer as a way to actually pull in policy into my mesh. And we'll talk about that, and we'll talk about that specifically in the context of API management. Pilot gives us the ability to basically push not only the routing rules, but also security policy to the proxies, in this case, in this example, Envoy proxies. This gives us the ability to do things like I can do A/B testing, I can do canary rollouts, again, all based on level 7 context. So this is kind of what Istio, some of the things that Istio provide. I think one of the key things here is we've got a little bit of an app. So we have an app. This is actually an app that was also shown at the keynote. But this is a Hipster App, and this is actually what it looks like. So there's around 11, 12 microservices. Some are written in Go, some are written in Node.js, some are written in Python. But this is just like a typical little microservices app. let's have a quick look at this, and let's have a look at what we can do with Istio with this. So let's transition to the demo. So here we have the Hipster store, right? This is everything that, I think that they said on the keynote, everything the hipster requires for a good lifestyle. So I'm going to actually, first of all, I'm going to grab a typewriter. Because I'm actually going to go and do some typing, I'm going to need some coffee. So I'll get a mug for my coffee. And then, maybe a little bit of music as well. I'll add that all to my cart. Oh, that's Wi-Fi demons have got me again. Okay, so here we go. Let's see if I can view my cart. Oh, we're good. Back up and running. Nothing like Wi-Fi in a conference environment to do a demo. Just when you can't possibly be more nervous. Anyway, so here we go. So we've actually got our Hipster store. We've placed our order. And we're back up and running. So let's actually have a look at what this actually looks like. So I have a single cluster running in Kubernetes. It's just relatively small cluster. On that cluster, I have a bunch of workloads. You'll actually see some of the same workloads that were actually in that diagram before. We have, a lot like the front end, the email service, but you'll also see a bunch of Istio components that are here as well. The other thing that we can do is if we drill into one here, you'll also notice that, okay, so for this particular service, I'm actually going to drift into the pod for a second. You'll also notice, I'm doing this a little bit quickly, but for this particular service, we also have in the same container or same pod, we actually have a sidecar. So this is effectively a transparent sidecar that's running co-located with that service. Okay, so what can we actually do? We've got our service running. Our sidecars are all deployed. Let's actually have a look at what we can do from a metrics perspective. So I'm actually going to come in here. I'm going to actually, I now have a bunch of standard Istio metrics that now are just available to me. I'm actually using Stackdriver, but these could be piped into any backend that you want. Whether a lot of people use Prometheus, Grafana as their standard backend of choice. So you can pick a backend of choice. I can actually look at those metrics very cleanly and very simply. The other thing that I can do is now I can actually get relational information. So this is the exact same application. Now I'm looking at a topology view of what my services are connected to. So if I look at front end and I highlight front end, I can now see my exact dependency. The other thing that's really key about this, so if you think about it, now if I've got a really large application, maybe hundreds of microservices, and I'm not exactly sure what my specific service is talking to, I can actually use a tool like this now to get access to that. I can also then go, okay, now I know exactly based on traffic who's communicating to who, and I can start using that to lock down my infrastructure. Create my access control policy for Istio security based on now this dependency graph. The other thing I can do is I can actually drill in. I can start seeing metrics for that. Again, very consistently, I haven't had to go through and implement any of this myself from a software development perspective. I can also start drilling in and actually have a look at the traces that exist within this environment. So that's kind of what I can see from a metrics perspective. Now let's actually say, Dave's a product management guy, and as a result of that, I like doing experiments. So let's. So the first thing I'm going to do actually is I'm going to. I see something that says reconnecting, which doesn't make me feel very comfortable. All right, here we go. All right, so we can see the pods that I've got running. I'm actually going to go through and deploy. Someone told me that blue makes people spend more money. So I'm actually going to go off and create a version of the front end that's blue. And I'm going to see that now blue's up and running. So now let's go back to my Hipster app. Now, as a product management guy, I don't really know too much about Istio and how it works and stuff like that. So you'll see here that about 50% of the time, I actually get a blue banner. Now, I actually have a load generator running in the background to get metrics, so it won't be exactly 50%. But I don't necessarily want to do that. Why would I actually just roll out a new front end and apply it to 50% of the traffic? So now what I want to do is, okay, so let's see how I can actually limit this down. I'm actually going to go through and create a new rule. So I'm actually going to create a rule. This is what the rule. This is the YAML piece, right? There is nothing like a product manager using VI and YAML. And so, fortunately for me, because I'm actually, I think there's a name for me at Google. It's called a Greygler, because I'm, old. And fortunately, they haven't changed the commands in VI in a long time. So it actually still works. But anyway, so we've got a rule. So this is a rule. We've actually got a rule that basically defines what gray and blue would look like from a policy perspective. Now, what I'm going to do is I'm going to apply that. The other thing I'm going to do is now I'm actually going to create that was interesting. Okay. So let's actually have a look at so I actually have a now I need to actually apply a rule to that. So I actually have a rule here that has basically everything now routed to just the gray. I'm going to apply that really quickly here. So I'm going to apply that rule. Once that is applied, I'll actually flick across, and with a bit of luck, look, we've actually restored things back to a nice harmonious state of everything gray. So now what I'd like to do is okay, now I actually want to control how much traffic goes to gray and how much traffic goes to blue. So I actually have now a different version of that rule that weights. Now one of the things is, this is actually where you start to differentiate from, say, Kubernetes, for example. If I had Kubernetes and had a bunch of different replicas on the back end, I can basically only control the amount of traffic based on the number of replicas. Where this actually gives me very fine-grained control, even though I've only got effectively two things on the back end. So now what I'm going to do is I'm going to take that exact rule, I'm going to apply that. So now, a bit of luck, and the demo gods are on my side, we should see roughly 1 out of, that's 2, 3, seems to be taking a long time to load, 4, here we go. Hey, yay! Come on, a round of applause. We actually finally got one. All right. Heart rate above 200. Not healthy for a guy my age. All right, so that's kind of what I wanted to show. So basically, that was just like a bit of a canary rollout. At this point, I'm actually going to introduce Nandan to come up. He's going to actually talk a little bit about API management. So we can actually cross back to the slides.
Thank you, David. All right, so I'm going to talk a bit about how API management fits with Istio. One of the questions I get asked a lot is, if I'm doing microservices, do I need API management? Or if I've got Istio managing my services, do I still need API management? Well, let's start with what is API management, right? And let's take a simple example. I've got service A, and service A is going to call service B, right? If service A and B are really built by the same team, then no, not really. You don't need API management. You want some documentation for service B, so it's well documented, so people who wrote service A know how to invoke it. But most use cases are not that simple. In a very large enterprise, you're going to have many, many teams building services. Service A and B are not built by the same team. The team that built service B wants to share that service with the rest of the organization, with third parties, with partners, who knows what else. So enterprises want to have a service catalog where APIs are published to that catalog. And this is different from a runtime catalog that Istio provides. A catalog that Istio provides is for Envoy and the sidecars to find services. This is more of a catalog for humans, for developers to come and read about that service. So in addition to documentation and a catalog, the next thing that enterprises would want is some way of governing who has access to which types of services. So once you onboard a developer, so some sort of developer identity is established, you then want to control which developer or developers can get access to which services. And as an API provider, I want to know which applications consume my API. Is it the branch application, or is it the call center application, or is it the mobile app? Which application is consuming me, the services that I built? Who are the developers who are writing applications that are consuming my services? That's the kind of view I want to have as an API provider. Some of those APIs you may even want to productize and monetize. Right? APIs are quickly becoming another channel through which enterprises are able to monetize their data. So when you want to productize and monetize those APIs, then again, API management is important. So these 5 factors help you decide if a service needs to grow beyond your team, needs to be shared with others, needs to eventually be monetized, then API management is important. There's another aspect. There are certain capabilities that you don't want every single service provider to build. Right? There are certain cross-cutting concerns. You've seen this in the form of API gateways that typically do the job of rate limiting or quotas. They do the job of caching. They do the job of some transformation mediation. There's some activities that you don't want every single team to build, so you build some sort of a service that they can all leverage. All these are factors that go into API management. So how do they compare? From our point of view, you need Istio to manage all your services. That could be a database service, a caching service, your web pages. These are all services, right? Some of those services become APIs when they're shared across your teams, across the organizations, right? And at that point, you need API management to manage those APIs. So all APIs are services, right? Some of those services become APIs, and you'll need to manage them. So how then do we compare the capabilities of API management and service management? I'm going to go through a couple of examples. On the face of it, they have very similar capabilities. But when you peel the layers, you'll see that there are some interesting differences. If you take monitoring as an example, service management focuses from a production operator's point of view. Right? They're more interested in latencies, they're interested in error codes, that's what they're interested in, and to pinpoint where exactly which service is failing or is behaving in a bad way. Right? But from an API provider's point of view, they want to know who are the top 5 applications consuming my service. That's sort of a business-centric view of who are my top consumers, what will happen if I make a change to a certain API, which applications are impacted that an API provider would be interested in. Even if you take an example like rate limiting, right? Istio will provide rate limiting at a service level, say 1000 TPS, right? That's how much my service can handle. But what someone in product management can decide is, I want my call center applications to get higher priority than, say, my mobile application, because I have more revenue impact if my branch services are not working as opposed to my mobile app. That sort of a decision of prioritizing your request can be done through API management. And of course, there are some capabilities like monetization that would only be applicable within the API management realm. So how then do we make API management work in an Istio Service Mesh? So let's bring you back full circle to what the Istio architecture looks like. This is the Istio Service Mesh. It's got all these standard components, and Citadel or security is not here, but easily it could have been in this picture. You're saying Mixer, you're saying Pilot, and you're saying the sidecar and ingress. The perfect point to introduce API management here is at Mixer. Mixer is a policy advisor to the Envoy sidecars, right? It tells Envoy when to allow or not allow traffic, right? That's extremely key when you're enforcing rules or policies. Also, Mixer is that point that is collecting telemetry data that you can ship it off to your API dashboards. What you'll see here is an implementation of that API management in a service mesh through Apigee. Apigee has extended the Mixer architecture to be aware of Apigee API management rules. So as a developer, you can define those rules centrally in the Apigee control plane of productizing your APIs, defining quotas, finding entitlements of who can access your APIs, also publish those services to the developer portal to determine who can see those APIs, the documentation for it, and so on. And when those services are now in the portal, consumers can come and subscribe to it and get developer keys to access that service. Once you've defined these rules in the Apigee control plane, Mixer downloads that information, and now that those Apigee rules are now present in the service mesh. The enforcement now happens at the sidecar level or at the ingress level, depending on how you've defined it. So let's take a look at this with an example. Right? We had the Hipster app, right? Let's say the requirements changed. It was mostly a web-based application that had a whole bunch of microservices backing it, and now we have a new requirement, right? The shipping service there also allows me to track shipments, right? And I want to expose this tracking API, if you will, part of the shipping service externally. So it can be invoked not just through the UI, but through a mobile app, through something else, right? How would we go ahead and protect this service? So that's what we'll do with the demo next. Switch to the computer, please. All right, there it is. So let's go first and get the ingress IP so I can go and access this API, right? Let's go do that. That's going to store the ingress IP. Let's make sure I have the IP address here. I have my IP address for the ingress. Now let's go ahead and access this API. All right, so I got access to my API. Now that's not a good thing, because I access that API by providing absolutely no credentials. So I want to go and fix that. So let me go ahead and apply a rule to change that. And I'll explain in a second what those rules are. There are actually 3 files here that I'm going to walk you through. 2 of them you do one time. This is a one-time setup to make your mesh API management affair, if you will. So the first is a definitions file. The definitions file creates custom resource definitions that tell the service mesh what attributes to look for. So if you're doing analytics, for example, what type of analytics would I want to be sent to the API dashboard? So I want things like the request URI, the path, the type of service that was accessed. There are a whole bunch of metrics that you want to collect, and the definitions file defines that metric for analytics. Similarly, if I'm defining API keys or OAuth, where do I look for these values? What values am I interested in is what you define in the definitions file. This is a one-time setup that a mesh operator does. Once you're done with that, the next is the handler. The handler creates a configuration that allows Mixer to communicate securely to the Apigee Edge instance. So within Apigee Edge, you'd have a tenancy, and so you've defined that, but now you want some sort of a secure way for Mixer to contact Apigee so it can get those rules. And the last is, when do I apply this policy? I've taken a very simplistic view here. This last step defines, when do I want this rule applied? In this case, I said, well, anytime there's an inbound traffic, apply these rules. You may want to be more selective here. You can say that, well, apply this rule only if the label is API, or apply this rule only if the namespace is API, or something like that. You can be more creative with when you want this rule to be applied. All right, so now that I have this rule applied, oh, that's not good. Right, let's try to access that API again. I got a permission denied, quite as expected, right? Because I applied the rule that says, no, I want to shut this down. I do not want unauthorized access to this API. So now when I try to access it, it obviously shut me off, right? Normally, what would happen now is that this developer would go into a developer portal and say, all right, I see the tracking API right there. I'd like to request access to this. And this developer gets an API key and would use that key now to access it. In the interest of time, I've gone ahead and gotten one such API key, and now we're going to try and access this service with my API key. Okay, so same call, but with the API key, except this time I am now able to access that service. So the mixer was able to verify this API key, was able to check against the entitlements. So first, was the API key valid? Then, was this API key allowed to access the tracking API? And then allow that request in. Also, what happened behind the scenes, and you'll see this in a few minutes, Mixer sent telemetry information about this API call to the API dashboard. All right. Now, more often than not, API keys are not sufficient for enterprises. They'd like to secure it with OAuth, right? Let's do very quickly if we can also do OAuth here. So I've applied a spec that's now going to implement or look for OAuth tokens. Let's take a look at what that file looks like. This is the OAuth spec that I have for the shipping service. What you'll see here are 3 pieces of info. One is, which service do I want protected? That's the shipping service. That's the target. And second, what issuer should I look for in the JWT token? And you can see the URL there. That's the issuer I'm interested in. And lastly, what's the JSON web key endpoint I can get? That's where the public keys are hosted. That's hosted in Apigee at this point. So how do I verify this token? Once this policy is deployed, Envoy will now check if the token is expired or not. And if it is not expired, if the public key is valid, right? I mean, does a digital signature be valid? But that's one step. That's almost like the authentication step. Make sure that your JSON web token is reasonable. But that's every JSON web token accessing every API then. What about the next step? Can this user access this API? So now those attributes are passed to Mixer. Mixer will still apply the Apigee rules to say, all right, is this JSON web token allowed to access the tracking API? And that's what we'll see next. So let's go ahead and get a token. Right, so I've got a script here that will allow me to get a token. So let's do that and store it in a variable. Let's look at that JSON web token. Really long string, where I'm going to now parse it and show you what that looks like. So let's go put that in a file so you'll see what is in that token. And let's try that. Okay, so you're seeing parts of that JSON web token there because what is inside that token is the API key or the client identifier for that JSON web token. This then allows Mixer to check if the JSON web token is really allowed to access this particular API. Because you may have a rule where this client ID can access a email service but not the tracking service. So that next step of entitlement check is also done by Mixer. So let's now call the same service using the access token instead of the API key. I got back my my JSON again. So what we've been able to do is to protect the API while defining certain rules in the service mesh. But what's also now interesting to see is if I can get this dashboard also show up in the API dashboard, because I want analytics for it. So I'm going to refresh this, and I get hourly metrics, day, week, and so on. At the moment, I'm just going to pick hour. I have a load generator running. So you'll see many more requests than I actually generated here, but I can dial down some of the Istio specific information and start looking at the shipping API, the response times here, and so on. But also, more importantly, look at some of the developer aspects of it. So who was the developer who built this shipping service? How many errors does this developer generate? So on and so forth is information I can get by looking at the API dashboard. All right, back to the presentation, please. Okay, so to quickly summarize, service management is needed for all your services, and when you share those assets with other teams, external vendors, and partners, API management is available for you. Now, David, for some announcements.
Yeah. So this has actually been mentioned before, but Istio 1.0 is literally right around the corner. In fact, I think there's actually even on istio.io there is a countdown clock for the exact time that they believe that, yeah, exactly, right? So 1.0, that's a pretty big deal. We also have managed Istio on GKE, which is going into alpha. So if people are interested in maybe a way to have a play with Istio in a GKE environment, let us know. Please reach out. We're actually taking people on that side. And we also have some Apigee API integration.
Yes, and that's going to be the GA the same day Istio is 1.0. So you guys can look up GitHub. It's also open source.